In this mini lecture, we'll cover a brief introduction to what's called the difference quotient. So let's see how we come up with it first and then go ahead later and apply it to a few examples. So we first start off with the graph of a function. Let's say this function is called f of x. It's a little curve and it has these 2 points there. So between these 2 points, the distance between these 2 points on the x-axis we'll call h. So h will be this distance between these 2 points on the x-axis. This point we'll label point P. Point P can have the coordinates of x, right? It has a x value and a y value for all coordinates. And we'll just call the other value f of x, right, which stands for y. This other point we'll call Q. So we have P and Q. Q, the x value for Q, since x starts right here to the left, then the x value for Q can be x plus that h that it travels. So then it must have a y value. So the y value will be f of x plus h, right? The y value that corresponds to the x plus h on the x will go right across and it'll be whatever it should correspond to. So we have those 2 points now, P and Q. If we next go ahead and draw a secant line through those 2 points. So I'll draw this in green. So the secant line, and it goes through the curve. So it goes through the curve and crosses at those 2 points, P and Q. So in joining P and Q with that secant line, we can go ahead and figure out the slope, right? And we know the slope formula to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. With this being so, we can go ahead and plug in what we have for y sub 2. Y sub 2 for us is f of x plus h minus y sub 1 is f of x. All divided by x sub 2 is the x plus h minus x sub 1 is x. All right, let's clean that up a little bit. And then we have f of x plus h minus f of x. And in the denominator, x plus h minus x, well, those two x's disappear, right? Because one's a positive x, one's a negative x. And then we have h at the bottom. So what we have here that we've come up with, this is known as the difference quotient. So let's hop right into our first example. It states, let f of x equal 2x squared minus 3, and to find and simplify the expression for the difference quotient. All right, so we know the difference quotient to be f of x plus h minus f of x, all divided by h. So we're going to use a 3-step process to go ahead and find and simplify this expression for the difference quotient. All right, so first we're going to find the first term in the numerator, f of x plus h. So first step, we're going to find the first term in the numerator for f of x plus h. Well, all that tells us to do is to substitute x plus h in everywhere we see an x in the original function. So again, we substitute x plus h in for x into the original function. So it looks to be 2x plus h squared minus 3 times x plus h. And going through this, we get 2 x plus h squared. On this one, you may have to go ahead and use some scrap paper, but this means x plus h times x plus h. So this is telling me x plus h squared to multiply it times itself. And when we multiply a binomial times a binomial, we would have to go ahead and FOIL, first, outer, inner, last. So what we get, and I'm going to skip an intermediate step in the FOIL method because that's something we can do on the side and match up our answers. We should get x squared plus 2xh plus h squared minus 3 times x plus h. Now we want to distribute this 2 through the entire parentheses. So we get 2x squared plus 4xh plus 2h to the second. All right. So now we go ahead and distribute that negative 3 to those two terms. So we have negative 3x, negative 3h. All right. So we just completed that first part of f of x plus h. Now we need to go ahead and subtract that f of x. So that will be kind of like my step 2. So step 2 is going to be to find the entire numerator. Find the entire numerator. So we found f of x plus h, but now we need to subtract f of x from it. So again, we have 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus f of x, right? Minus f of x. So what was f of x? F of x is the original function. The original function is 2x squared minus 3x. So now we have to clean it up a little bit. So what I'm going to do to clean it up is distribute again, right? Because I see it's subtracting this entire quantity. So with polynomials, when you subtract a whole quantity, it's like distributing a negative 1 through. And then I'm going to combine like terms wherever I have them. So 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus 3x. And I apologize, that's not 3x. I'm sorry, yes, it's positive 3x. So I want to make sure I get my signs right. Negative times negative makes that a positive 3x. All right. And then what I want to do is combine like terms wherever I see them. Well, this positive 2x to the second down here, positive 2x to the second, and negative 2x to the second, they'll make 0. They'll 0 out. Then we have a negative 3x and a positive 3x. They'll also 0 out. I don't think any more terms 0 out. So looks like we're left with 4xh plus 2h squared minus 3h. So we found the entire numerator. Lastly, our third step is going to be find the difference quotient by dividing by h. Dividing by h. So we have 4xh plus 2h squared minus 3h. And this is divided by the h that's in the denominator of our difference quotient. So it looks like we'll be able to divide each term by this h. Each term. An easier way may be for us to go ahead and factor out an h in the numerator, right? Because 4xh has an h, 2h squared has an h, and 3h has an h. They don't have any numbers in common, so h will be my GCF. So h goes into 4xh, 4x times, h goes into 2h squared, 2h times, h goes into negative 3h, negative 3 times. And that's all still divided by h. Well, we know that we can cancel those out, and we're left with 4x plus 2h minus 3. Let's step into another example. So we have f of x equals negative 2x plus 5. All right, and applying the difference quotient first, the first step is to find f of x plus h. So this means just to go ahead and plug in the x plus h in everywhere we see an x. So we have negative 2 times x plus h plus 5. So we need to go ahead and distribute. That gives us negative 2x, negative 2h plus 5. There doesn't seem to be any more I can do as far as combining like terms or anything. So I go on to my second step. My second step is to go ahead and subtract f of x. Well, what's f of x? F of x is that entire negative 2x plus 5. So I subtract negative 2x plus 5. So I need to clean that up a bit by distributing, right? Because it's subtracting that whole quantity. So in essence, we can distribute a negative 1 through. So negative 2x minus 2h plus 5. Negative times a negative makes this a positive 2x. Negative times a positive makes this a negative 5. All right, so my third step is to divide this by the h that's in the denominator. So negative 2x minus 2h plus 5 plus 2x minus 5. And I'm going to divide by h. But before I do that, let's just go ahead and make sure that we can combine any like terms at the top in the numerator. So the negative 2x and the positive 2x zero out. And then we have a positive 5 and a negative 5. They zero out. So let's see what's left. What's left for us is negative 2h over h. And in doing this division, we see that we can cancel out the h's, and we're left with negative 2. All right, I hope this video helped you. Feel free to share with any others that it may be helpful to. Don't forget to hit the like, share, and subscribe button. Take care. Have a good day.